All right, folks, so we are starting today on page 2 in the notes, and today we are going to be adding and subtracting fractions. So in order to add and subtract fractions, we have to have a common denominator. And when we are dealing with these big, nasty denominators, it's not just important to find a common denominator. We want to find the least common denominator, or the LCD. So least common denominator. This is going to keep these fractions as small as possible and lead to less simplifying. So going back to that example we did on the first page when I was trying to add 1/2 to 1/4, could I have taken those up to, instead of a common denominator of 4, all the way up to 8? Well, sure. I could have multiplied this by 4/4, which would have given me 4/8. And then I could have multiplied this one by 2/2, which would have given me 2/8. And then when I add those tops together, we would have gotten 6/8, which then simplifies to 3/4. So sure, we can use 8 as a common denominator here, but it does create that extra step of simplifying, which isn't too bad when we're just dealing with regular numbers, but when we start dealing at these big rational expressions, we do not want to create any extra steps, and we do not want to create any bigger items than is necessary. So this is why we are going to spend some time trying to find the least common multiple. How we do it is we are going to factor and take the largest amount of each factor. So we are going to factor and take the largest amount of each factor. Now, if I were you, that would seem kind of counterintuitive. We're looking for the least common multiple, but we're taking the largest amount of each factor. But if we go back to that example on the previous page one more time, if I look at the denominators of 2 and 4, we want to go up to the bigger value of 4 because it's easy to multiply to get to that bigger value. So that is why we are taking the largest amount of each factor. And I want you to add in here factor and factor tree. So if you remember doing factor trees from middle school, they're going to come into play a little bit with finding some of our common denominators. Now, as far as the steps go for this process, I'm never going to be like, what's step 3 of adding fractions together? You don't have to memorize these word for word. You don't have to memorize the sentences at all, but you do need to know how to work these in each of these problems. So we're going to start with the first example. And just like yesterday, we're actually going to start by identifying our operation. Since it's addition, we know that we are going to need to find the least common denominator. So the LCD. So we are going to factor tree and take the largest amount of each item in the denominator. So I've got 2. And then 8 breaks down into 2 and 4. And 4 breaks down into 2 and 2. So I'm breaking it down using a factor tree. So if I'm looking at the numbers, what's the largest amount of 2's that I have in one of those denominators? These 3 2's. So I'm going to take that as the largest amount and say 2 times 2 times 2, or 8, is going to be the number part of my LCD. Then we look at our x's. What's the largest amount of x's that we have in one of those denominators? The x cubed. So x cubed will be part of our LCD as well. And the largest amount of y's that we have in one of those denominators? Y squared. So on your homework, I am going to have you state the least common denominator, the LCD. because finding it is going to be a large part of your work and it's going to help me determine partial credit on these. So step 1, find the least common multiple of the denominators, and this will be your common denominator. So least common multiple of the denominators. Now step 2 says multiply both fractions, numerators and denominators, by whatever the denominator is missing to get to the common denominator. So we're going to multiply by what the denominator is missing to get to the common denominator. This is the step where we use our creative forms of 1. So right now these denominators are different. If I write out the first fraction, we have 3y over 2x cubed. If I need this denominator to look like the least common denominator, what will I need to multiply 2 by to get it to look like 8? 4. But I'm not the god of math. I can't just multiply by 4. We'll have to multiply by 4 over 4 so that I'm multiplying by 1. What can I multiply x cubed by to make it look like x cubed? 1 or nothing. We've already got the x cubed that we need. What else do we need to get a match so that this denominator will look like our common denominator? Y squared. So that's what we will use for our creative form of 1 for the first fraction. Second fraction. We have 5z over 8xy squared. How do I make this denominator look like the least common denominator? We've got the 8. What don't we have? The x cubed. So we will need to multiply it by x squared over x squared to get to the common denominator. So now, how do we multiply these fractions? We go straight across. So we multiply by going this with this, that with that, this with this, and that with that. So 3y times 4y squared, what will that give me? 12y cubed. What are we going to get in the denominator? That least common denominator. 2 times 4 is 8. Then we've got the x cubed and the y squared. Then plus, on the top, 5z times x squared is 5x squared z over 8x cubed y squared. So we found our least common denominator. We chose creative forms of 1 to get to the common denominator. So now that those denominators are the same, what am I going to do with these fractions? We're going to add them together. So I'm going to take this one plus this one. Oops, kind of got messy with the z there. We are going to add just the tops together. Now, can I actually add 12y cubed to 5x squared z? No, they're not like terms. So all I can do is write it as one fraction over that common denominator. Can I simplify this by taking an x squared out of here and here? Oh, this goes into what we did yesterday. If I were you, once you get to this point, I would trap that binomial in parentheses. But step 4 is we should try to factor and cancel out any common factors if we can simplify. Take a look at that binomial on the top. Is there a GCF or anything I can factor out? So we're stuck with it, and I want you to just put a note that you can't factor. So We can't simplify. So that is our final answer. Oop, I did miss the Z. Geez, I crossed it off so much we couldn't even see it. So Z. Thank you. So yep, we have the Z as part of that top as well. So no GCF, that would be our final answer. Now, if you're looking at that going, how is this better than what we started with? The whole goal is to carry out the operation. We had addition of 2 fractions, and we turned it into 1 fraction. So that's kind of our goal with multiplying, with dividing, with adding, with subtracting is we want to try to get it to 1 fraction. Let's go ahead and look at our next one. Now for this problem, we identify our operation as multiplying. I want you to put a little, as subtraction. I want you to put a little star by this. Anytime you have a subtraction out in front of a fraction, what I do is I distribute that negative to both parts of the numerator. So I'm going to make this a plus sign and distribute that negative to the x and distribute it to the 1. I strongly recommend doing it as the very first step. That way you don't lose that negative in any of these wild steps that we do, and you won't forget to subtract both parts of the numerator. So anytime you have subtraction, distribute the negative to the top. Kind of like how anytime you have division, immediately turn it to be multiplying by the reciprocal or keep, change, flip. So now we want to find our least common denominator so that we can turn these 2 fractions into 1 fraction. So we start by factoring the denominators. Now here we have binomials. So not only can I factor tree the monomials, we will need to do our regular factors for our binomials and trinomials. So actually up where we wrote factor tree, I want you to write monomials. So like I wouldn't want to do the factor tree of 6x and the factor tree of negative 18. I would only want to do that for my monomial denominators. So regular factoring styles, what would I do to factor 6x minus 18? We got a GCF. Take out the 6. And we have x minus 3. What about the next part? The next denominator. What are we going to do to factor that one? GCF again. So take out a 2 first, and 2x squared minus 7x plus 3. Sorry. So take out a 2 from both of those. All of those. Can we factor either of these further? We can. We can use the x method here. So 1x and 2x. And let's stack 3 and 1 so that we get 1x and 6x, and both need to be negative. And remember, folks, we saw a problem yesterday where it's very important that we check to make sure we are getting the correct product number. Negative 1 times negative 3 is a positive 3, so we have figured out the correct factorization. So my full factored form for this one, we're going to have 2 and x minus 3 and 2x minus 1. Can I factor further? So we can't factor any further than what we did for like our normal multiplying and dividing problems, but I can break down that 6 into 2 and 3. So we want to break down any monomials, which is usually going to be our GCFs. We want to break those down into their factor trees, just like we did over here, so that we can take the largest amount of each item. So folks, what's the largest amount of 2's that I have in one of these denominators? 1, 2. So it doesn't matter which one you circle, but 2 is going to be part of my least common divisor. What's the greatest number of 3's that I have in one of these denominators? 3. And this makes sense when you think about trying to get to the common denominator. If I've got 6 and I've got 2, can I make the 2 look like the 6? Yeah, so the 6 is going to be our common denominator. So 2 times 3 will give me 6. What's the greatest amount of x minus 3's that we have? Just 1. So there's 1 in this one, 1 in that one. So that's going to be part of our common denominator. The greatest amount of 2x minus 1's that we have is 1. So I'm taking the largest amount that I have of each factor, and that gives me my least common divisor, my least common denominator of 6, x minus 3, 2x minus 1. So now our goal is to make these fractions both look like they have a denominator of 6, x minus 3, and 2x minus 1. So we've got 5 over 6 x minus 3. Notice that when I'm rewriting that first fraction, I'm using the factored form. What am I going to use for my creative form of 1 to make the denominator I have look like the common denominator? We're going to need to multiply by the 2x minus 1. And 2x minus 1 is a binomial, so I'm going to go ahead and trap that in parentheses on both the top and the bottom. Draw a little line here, separating my work. Then plus my second fraction, negative x plus 1 over the factored form, 2 times x minus 3, 2x minus 1. Now looking at the denominator we have versus the denominator we want, how are we going to make the 2 look like a 6? Multiply by 3. How are we going to make the x minus 3 look like x minus 3? We've got it. The 2x minus 1 look like 2x minus 1. We've got it. So the only thing I need to do to this fraction is multiply by 3 over 3. And now we multiply. Now with multiplying these more complicated fractions, what I would like to show you is that we are always going to distribute on the top, so 10x minus 5. But on the bottom, we are just going to slide those denominators together by multiplying to make it look like the common denominator. So I'm just going to leave it in that factored form and slide that 2x minus 1 right next to the x minus 3. Then for my second fraction, I'm going to need to multiply by 3 here. Since this is a binomial, I will have to distribute to both of those. So negative 3x plus 3 all over. Now when we slide these denominators together, just like we did for multiplication, we're going to put the monomial parts together, making it 6. X minus 3, 2x minus 1. And behold, we now have the common denominator for both of them, which is what's going to allow me to add the tops of my fractions together. Now, when I add those tops, is there any simplifying that I can do? Are there any like terms we can add together? We've got 10x and negative 3x, which will be 7x. And then we've got negative 5 and positive 3, which is negative 2. And this is all over that common denominator of 6 times x minus 3 times 2x minus 1. And we don't want to FOIL all of that out because we want to leave that denominator in factored form in case there's any simplifying to do. So take a look at that numerator. Can I factor 7x minus 2? Nope, can't simplify. So can't factor, can't simplify. So we're going to pull back for a moment and take a look at the differences between these two problems. This one had purely monomial denominators, and we had to use factor trees to take the biggest amount of each individual factor. This one had a combination of binomials and trinomials, and when we took out GCFs, factor trees for those monomial parts. So the hardest part about this is figuring out the common denominator first by factoring, and then in the process, we want to slide our denominators together to get the common denominator and distribute on the top so we can add those together. What questions do we have so far? We don't have questions, Ms. Carr. We just don't like it. As I said, adding and subtracting is hard. So we're going to do lots of examples together before I turn you loose on any of these on your own. So we're going to go ahead and go down to our next problem. First, we have 3 fractions. Oh, goody. We identify our operations first. We've got addition and we've got subtraction. Just like division should make you think, keep, change, flip. For subtraction, I want you to instantly turn it into a plus sign by distributing the negative to the top. If you're like, why the top? Why not the bottom? We don't want to deal with negatives when we are finding a common denominator, so sticking it with the top of the fraction is the easiest place for it. So next, let's try to find our common denominator by factoring the denominators we have. So x squared minus 9x plus 8. Can I factor that? Yes. Product of 8, sum of negative 9, x minus 8, x minus 1. And then my other denominators, x minus 1, can't factor that any further, and x minus 8. So I don't need to do any factor trees on this one because I am dealing with all binomial factors. So I want you to just take a guess at you can call it the LCM or the LCD. So if you see me write an LCM, that's why. So least common multiple or least common denominator, LCD. So what do you think would make sense to use as my LCD? Can I make these 2 smaller denominators look like that larger one? We could. This has x minus 1. This has x minus 8. So if we take the largest amount that we have of each factor in one denominator, I've got 1x minus 8 here. I've got 1x minus 8 over there. So the largest amount of x minus 8s that I have in one fraction is 1x minus 8. We've got 1x minus 1 here. We've got 1x minus 1 there. The largest amount that I have in one fraction is 1. There's my least common denominator. So as I go to write the first fraction, we've got x squared plus x over x minus 8, x minus 1. Now, if you're looking at that top going, shouldn't we try to factor the top too? Not at this point because the numerators or the tops of the fractions don't have any bearing on what we use for our common denominator. So this is the denominator I have. This is the denominator I want. What are we going to use for our creative form of 1? We don't have to do anything with it. This already looks like the LCD. So I don't have to manipulate this fraction at all, just like on the first page of our notes. When I was trying to make 1/2 look like 1/4, 1/4 was good as is. We didn't have to do anything to it to make it look like the LCD of 4. So that first fraction is good. So you can just put a note that we already have the LCD. We move to our second fraction, 4 over x minus 1. This is the denominator we have. This is the denominator we want. What will we use for our creative form of 1 on this one? X minus 8 over x minus 8. We move to our third fraction. So plus negative 3 over x minus 8. This is the denominator we have. This is the denominator we want. What are we going to use to get to that common denominator? X minus 1 over x minus 1. Woof! So much work! Fractions all over the place. So we factored our denominators. There were no monomials, so we didn't have to do factor trees. We used the biggest amount of each factor that we had within each fraction. So folks, if this had been an x minus 8 squared, I would use x minus 8 squared because that's bigger than the one that we have over there. So a lot of times you're just going to use one of each factor, but if there is more, you will use the biggest one. And then x minus 1, we have one of each of those. So 1 is the biggest amount that I have in one denominator. Then we multiplied by whatever each fraction was missing in terms of the common denominator. Now, folks, I am showing a lot of work on these because I think it's important to see where each of these parts are coming from. I do have students who sometimes will just write x minus 8 kind of lightly off to the side here, x minus 8 here, and then they'll write x minus 1 real little there and x minus 1 there. As we start doing more of these, you may be able to show less work or take up less space with your work, but in the notes where we have all this lovely space, I want to show as much work as possible so you can see where each of those parts is coming from. What questions do you guys have on the first couple of steps? Let's go ahead and move to step 2, which is multiply both fractions by the creative form of 1. So nothing to multiply here, so this is just going to stay x squared plus x over the LCD. Then, for my second fraction, we distribute on the top for x minus 32, and then slide the denominators together, which will give us the LCD, x minus 1, x minus 8. So that sometimes throws students off that we're leaving the denominator in factored form, but we're distributing on the top so that we can actually add our like terms together. Then for our last fraction, distribute, distribute. So negative 3x plus 3 all over, slide the denominators together. So x minus 1, sorry, minus 8 there, and then x minus 1. Question?
Why didn't you slide the first one?
Why didn't I slide on the first one? Because we didn't even have a creative form of 1 to slide to, so that denominator already is the LCD, so that's why we didn't have a pink creative form of 1 on that one, because it was already good.
Right.
So now from here, we have a common denominator. X minus 8 times x minus 1, x minus 1 times x minus 8, x minus 8 times x minus 1. So now that those denominators are the same, only then can we add the tops of our fractions together. So let's go ahead and find any like terms that we have. Any like terms for the x squared? That's a no. So x plus 4x, 1x plus 4x is 5x, and 5x minus 3x is 2x. And then we've got negative 32 plus 3, so negative 29. All over the LCD. X minus 8, x minus 1. Before we put a box around this, what should we try to do? We should try to factor. to see if we can simplify that top at the bottom at all. So product of negative 29, sum of 2. 29 is prime, so yeah, that's not happening. So this is prime, so we can't factor. So we can't simplify. So now we can put a box around our final answer. Moving on to the next problem. We identify our operation. We have subtraction. So I'm immediately going to change it to addition and float the negative up with the top. I want you to try to find the LCD in the next 2 minutes. Factor the denominators, factor tree any monomials if necessary. See if you can find the LCD. Let's start with factoring that first denominator. Product of negative 6, sum of negative 1. Anybody got it? Perfect. X minus 3 and x plus 2. There's the negative 6 we want, and then there's the negative 1 that we want. Now, as you're looking at 5x plus 10 going, that's a binomial, baby. You are right, but can we factor it? What can we do? GCF, those sneaky GCFs. I want you to write GCF in big letters. Those are the ones that tend to throw people off. And if you're like, well, big deal, I'll just use 5x plus 10 as a factor. Folks, if I use 5x plus 10 as a factor, my least common denominator is going to have all 3 of those. So I'd have to multiply this one by 5x plus 10. I'd have to multiply this one by 2 of those things and superfoil. Do I want to do that if I don't have to? Yeah, absolutely do we not want to do that. So by taking out that 5, that leaves me with x plus 2. So now I see that these have the x plus 2 in common, so it'll be part of my common denominator, but I won't have to multiply either of those for the creative form of 1. Now, 5 is a monomial. Can I factor tree that? Nope. 5 just stays 5. So our least common denominator, the greatest amount of 5s that we have is just the 1 5. And the greatest amount of x plus 2s that we have is just 1. The greatest amount of x minus 3s we have, 1. How'd we do on that one, finding the common denominator? Hopefully the factoring part went well. I know taking one of each is kind of confusing, but if it's hard for you up here, you can kind of figure out your common denominator when you go to say, what do I need to make it look like the other one? So if I write x minus 1 over x minus 3, x plus 2, if I say, how do I make this stuff look like that? We've already got the x plus 2, so the x plus 2 is part of it. We've got the x minus 3, so that's going to be part of it. We're missing the 5, so the 5 is going to be part of it. So kind of putting it all together is how you can get your common denominator as well. So we are going to multiply by 5 over 5. See if you can determine the creative form of 1 for the next fraction. We've got the 5. We've got the x plus 2. We're missing the x minus 3. And I am trapping that in parentheses because I am going to need to distribute on the top. So we've chosen our creative forms of 1. So I'm going to have to distribute the 5 to the x and the 5 to the negative 1. And I'm going to have to distribute this negative 4 to the x and the negative 4 to the negative 3. What do we do with the denominators? Slide them together to make it look like the least common denominator. Folks, I want you to go ahead and try to write the next line of work. Show that multiplying, show that sliding. So 5x minus 5 over the LCD. And then negative 4x plus 12 over the LCD. How do we do? Next line of work. So now what do we do? Now that we have the common denominators, what do we do all that work for? To add the tops together. So now that these are the same, we can add those tops together. So 5x and negative 4x gives me a x, or 1x. And negative 5 plus 12 is 7. So x plus 7 all over 5 times x minus 3. Plus 2. X plus 7, binomial. Can I factor or simplify this? Nope, that's our final answer. So can't factor, can't simplify. So folks, that takes us to the end of notes for today. So after lunch, we are just going to be hitting it with practice. So let's go ahead. We have a few minutes. Actually, no, we're good. We'll start the guided practice after lunch. You guys can just relax the last few minutes. Yes.